Hello everyone, and good morning or good afternoon depending on where you are joining us from, and welcome to today's webinar. My name is Annabelle Chaplin from the Business Review and I will be your host. It's our pleasure to have ExxonMobil with us today, who will be discussing optimizing performance with biodegradable lubricants. Today's guest speakers are Olivier Boissel, EAME Industrial Products Technical Advisor, and Max Carlovini, the Industrial Lubricants Field Engineer. I'd like to welcome you to our webinar platform On24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask questions, you can send them in via the questions widget, which is located at the top left-hand corner of your screen. We will allocate around 10 to 15 minutes at the end of the session to address any questions or thoughts that you may have. If you click on the survey widget, there are a few questions in there for you to answer in order to provide feedback. You can do this during or immediately after the webinar. Please use the yellow help widget if you require any assistance. You can also move, resize and maximize the windows in front of you in order to get a better view. But now, please allow me to welcome Olivier Boissel.
Good morning, good afternoon everyone, and thanks for joining this webinar where today it will be my pleasure to discuss how you can optimize your operations thanks to high-performance biodegradable lubricants. Here is an overview of what my colleague Max and I will present today. First, I will set the scene for the need of EL and biodegradable lubricants, and then develop the benefits of our most recent technology, the new mobile SHE hydraulic EL. I'll detail how the product superior performance will bring your benefits in terms of safety, environmental care, and productivity. And these are the three important themes that we at ExxonMobil have defined under the Advancing Productivity pictograms. And they result from market research to identify which themes are most important to our customers and to our OEMs. Then we will see how the new mobile SHE hydraulic EL has a unique balanced performance, and I'll show you what OEM and industry claims we are able to meet. My colleague Max will then be able to show you a few things about product conversion, compatibility, storage stability, as well as condition monitoring. And we will wrap up with a summary and conclude with a short Q&A session. So let's start with a few general comments on the EL or environmental acceptable lubricants. This topic is becoming more and more important because in recent years there has been a growing trend for biodegradable or sometimes called bio-based lubricants in all applications that have a close interface with the environment, such as offshore operations or mobile equipment which are used in forestry, agriculture or mining. And this growing trend is driven by increased pressure from regulators and governments, of course backed up by the public, to reduce the environmental impact of all these industrial activities and also ensure sustainability of our natural resources. So because of these tighter requirements, stricter enforcement and penalties or fines for non-compliance, all the industry sectors are being challenged. And I would like to mention that historically biodegradable lubricants were not able to perform so well as conventional mineral lubricants, and I hope during the course of this deck I will be able to demonstrate that recent technologies are not trading off performance for biodegradability. So first, what do we mean by biodegradable? Well, in theory, everything will eventually degrade, but the important criteria is how much time it will take. So there are essentially two terms used with biolubricants: inherently on one side and readily on the other side. Both terms qualify biodegradable products, but they describe different levels in biodegradability. Currently, the most common method for evaluating biodegradation is the OECD 301B, and it is measuring the quantity of CO2 that is generated over a period of 28 days. And consequently, from that, you can deduce the actual quantity of oxygen which has been consumed when the molecules were exposed to bacteria. So the level of biodegradability is reported as the ratio of oxygen consumed versus a theoretical oxygen demand, and three levels have been defined. If the ratio is above 60%, then we are talking about readily biodegradation. And in this category, as you can see on the chart, there are a few oils like PAG or polyalkylene glycol, synthetic esters, or of course vegetable oils. Now in the second category, if the biodegradability ratio is between 20% and 60%, then the product is considered or defined as inherently biodegradable, and that's where you will find mineral oils, which eventually will biodegrade but at a slower pace. So everything above 20% is biodegradable by definition, but when we talk about biodegradable lubricants, what we really mean is readily biodegradable lubricants. And just before I move on to the next chart, there is a third category below 20% where we consider the product is not biodegradable. So as I've just mentioned in the previous slide, there are several types of biodegradable fluids. And here, let's have a quick review of the pros and cons of these fluids. Well, the first obvious one is water, but although not per se biodegradable, it has no impact on the environment. But as everybody knows, its lubricating properties are quite poor and is rather considered a contaminant in hydraulic fluids. Then the first type of oil that comes to mind in terms of biodegradability and renewability is, of course, vegetable oil. They are relatively inexpensive, but demonstrate high viscosity index and also high flash point. But the main disadvantage of this type of oil is that it is linked to performance with time, because they lack oxidative and thermal stability, and also they have a rather high pour point. Sometimes these oils are referred as triglycerides or HETG in the ISO standard, ISO 6743-4 for memory. The second category are the PAGs or polyalkylene glycols. They're also known as polyglycols or HEPG, and they have a high VI, and they perform well at low and high temperature, but one of the inconveniences is that they are incompatible with other oils, and they can create some issues with seals and paints. And sometimes they require finer filtration because particles are less prone to settling due to the high molecular weight of this type of oil. And the last category are the esters or synthetic esters, also called the HEES in the ISO standard. They are made of organic acids and alcohols, and they are actually accumulating the most advantage for hydraulic applications. They demonstrate excellent and long-lasting performance at temperature extremes. They also provide excellent lubricity, and they are compatible with mineral oils. So now I would like to introduce the new Mobil SHE Hydraulic EL and tell you more about its benefits. So first of all, at ExxonMobil, we are very committed to safety, and that is the first of three pillars of our advancing productivity themes that I mentioned earlier. And this advancing productivity pictograms, you will find them in many marketing brochures or even on labels. So in the next few slides, I'd like to say a few words on how this new product can improve the safety of your operations. Well, when you think about it, each time you need to fix something on your hydraulic circuit or each time you need to perform a general maintenance, there are some non-routine operations that can expose your operators to increased risks. And thanks to this product, you will be able to run longer with trouble-free operations, and the system will be cleaner and will experience less wear. So you will need less operation on your system. So let's see how this has been quantified, and I will report a couple examples of the tests we have done. So here, and that is the first test we have done to quantify what we call durability. This is a pump wear test, and we have tested the mobile SHE hydraulic EL in the Eaton 35 VQ25 vane pump test, which is an industry standard, and that actually measures the performance, the wear performance, and we got very good ratings in terms of rings and vanes compared to the maximum specification. So that shows excellent wear performance, and that can be directly translated into longer equipment life. So we have tested similar, we've done similar tests with a Denison pump, and thanks to that we are able to claim Eaton and Denison approvals. So the second test I wanted to mention is one that ExxonMobil has developed to better replicate the real world conditions and even make them a bit harsher. This is an in-house proprietary test that is called MHFD, for Mobile Hydraulic Fluid Durability Test, and is running around 80 degrees in the presence of metal catalyst and a bit of water. So this test is more relevant than glassware test and is recognized by the global equipment builders, and we use this for our extensive product endorsement program with EB and OEMs. So in short, this test is rating the cleanliness of the reservoir, and the peaks showed here are the bottom of the reservoir, and it also rates the cleanliness of the filter, but I didn't show peaks here for that. So you check after a few hours of operation, and as you can see, after 500 hours, if you look at the top right picture, this is representing a standard monograde ISO 46 mineral hydraulic fluid. And on the left, top left side, you can see after 500 hours the result with the new mobile SHE hydraulic EL 46. And on the bottom, even after 6,000 hours of operation in these conditions, you see that the bottom of the reservoir is relatively clean compared to the standard mineral oil at 500 hours only. And just for your information, if you already know the mobile DT10XL 46, we get the similar results after 4,000 hours. So the new mobile SHE hydraulic EL 46 is performing a bit better than the mobile DT10XL. So now, how can this new product range can help you address environmental care? Well, mobile SHE hydraulic EL is formulated with premium synthetic esters, and that makes it a readily biodegradable lubricant. And thanks to that, we are able to meet the EU Eco label as well as the USDA bio-preferred requirements. This product line is non-bioaccumulating, and it also shows minimal toxicity, which are key characteristics to reduce the potential for environmental damage in case of exposure to the environment. And last, I would like to mention, as this product is launched globally, that it also meets the US VGP requirements. So when we compare the bio-based content of the new product, we see that it exceeds by far the minimum requirements for the EU eco-label, which is 50%, and the one for the USDA bio-preferred, which is 45% of bio-based carbons. So actually the area in green represents the renewable content, and it is measured by the STM D6866, which is able to discriminate carbons from the fossil origin from carbons with bio-based origin. So in this slide about biodegradability, I already explained how biodegradability is defined and measured. And these results are obtained with the OECD 301B method. And based on these good results, we are able to claim that the product is readily biodegradable, as the values are above 60% after 28 days. So in addition to performing well with respect to biodegradability, aquatic toxicity studies on the new product demonstrate that the fluid exceeds the requirements set by the regulator. And thanks to these good results shown in the table, it ensures that no classification for environmental hazard is required for this new range of product, and of course it's of particular importance for mobile equipment operating on waterways. So as I mentioned in the introduction, the regulators are becoming more and more strict, and the good environmental properties of the mobile SHE hydraulic EL could actually save you money in case of accidental spill, because as among factors that I listed below that the authorities are looking at to evaluate the impact, they are first really interested by the impact on the environment of the product. So now let's see how the new mobile SHE hydraulic EL can also directly impact your productivity, because after all, that is where you will be able to see immediate benefits on a day-to-day basis. So the mobile SHE hydraulic EL can directly impact your productivity thanks to, on one side, a wide operating temperature range, as well as cost savings resulting from higher energy efficiency. So in practice, you will have less difficulties to start up your equipment, and the late afternoon sluggishness that some of you may experience could be reduced. And of course, the energy efficiency will allow you to extract the maximum performance of your equipment at reduced cost. So let's see how these two claims are being supported in the next few slides. So here on this chart, it shows the operating temperature range of each fluid. So you have the ISO 32, 46, and 68, and in red you have a standard monograde hydraulic oil, and in blue you have the new mobile SHE hydraulic EL. So the minimum operating temperature is determined to be the temperature at which the maximum viscosity of the fluid is 860 centistokes. And on the other hand, the maximum operating temperature is determined to be the temperature at which your oil reaches a minimum viscosity of 13 centistokes. So this 13 to 860 centistokes is an internal ExxonMobil range, but it's a mix of various gear, piston, and van pump specifications set by the OEMs. So as you can see, to summarize this chart, is that with the new product you have an operating range 10 to 15 degrees wider than for a standard monograde hydraulic fluid. As we saw on the last slide, the product has a wide range of operating temperatures, and in order to achieve this goal, the fluid must have a high viscosity index, but also needs to be shear stable. And these two characteristics actually bring benefits in terms of energy efficiency. And as you probably know, there are two types of energy losses in a hydraulic system. On one side, the mechanical losses, and on the other side, the volumetric losses. And to reach the optimum hydraulic efficiency, you need to achieve a viscosity sweet spot, which is greatly increased with a shear stable high VI fluid. So if the high VI fluid is not shear stable, then the viscosity will be reduced with service. In the next slide, a bit of theory. So what we can see here is the overall efficiency as a function of viscosity on the bottom axis, and as a function of temperature on the top axis. Of course, both of them are in opposite direction. So on one side, the mechanical efficiency, which is the blue curve, improves as the temperature increases, and because the viscosity decreases, so there is better flow. But on the other hand, the volumetric efficiency, which is the yellow curve, will decline quite sharply as the temperature increases, because then you have more and more internal leakage in your pump. So the overall efficiency, which is materialized by the red curve, has a maximum in an optimum operating window. And that operating window is where the viscosity of the oil is at its optimum for a given system. So what I can say again on this chart is that after a cold startup, the efficiency, overall efficiency will slowly increase, reach this optimum, and then can sharply drop. For example, at the end of the day, well, you will experience equipment sluggishness, which is called sometimes the PM fade. So what you need to remember out of this is that maintaining the optimum viscosity over a wide range of temperature actually increases the efficiency of your operations. So now let me give you a few examples. Here, the hydraulic efficiency was measured on a rig test with a Eaton 25 VMQ vane pump. And each blue bar is the average of three different measurements, and the baseline 0% was obtained with a typical non-VI improved conventional hydraulic fluid with a VI of 100. So the temperature and pressure, 60, 80 degrees and 250 bars, are typical of injection molding machine, for example. And as you can see, for a normal temperature of 60 degrees, we were able to reach about 1.5, 1.6% energy efficiency gain. But as you increase the temperature, then you will gain more energy efficiency, or there will be more difference compared to the standard hydraulic oil, because the standard one will have a drop in viscosity, while this mobile SHE hydraulic EL, thanks to its higher VI, will be able to maintain a higher viscosity at high temperature. So as you can see here, and this disclaimer, energy efficiency was also on the previous slide. The efficiency can vary based on the operating conditions and the application. So that's why we tested in two different pumps. First the Eaton one, and now this Denison T6H20C hybrid pump, but at higher temperature, 95 degrees here, which is more representative of hydraulic or hybrid pump operating temperatures. And here again, we are in the range of 3.2% of efficiency gain. So after the last few slides demonstrating how advancing productivity is achieved, I'd like to unveil a few other key general characteristics of this new mobile SHE hydraulic EL. And I will also provide an overview of its performance and claims. So in this table, I reported the key characteristics that you're expecting for an hydraulic oil. And I won't go through each line, but what I'd like to highlight is that there is a very low pour point as well as good demersibility, and the foam characteristics are pretty good. And as you probably know, one key attribute for hydraulic oil is air release, and a good air release actually will ensure that more power input to the fluid is actually converted into power output, because air is more compressible than the fluid, and untrained air can result in a decrease in energy efficiency or inefficiency of your system. And in addition, untrained air can also potentially damage your pump due to excessive wear when the air bubbles are collapsing or imploding when the temperature is dropping. The pressure is dropping. So in this chart, the fluids A to J are competitor EL hydraulic fluids that you can find on the market today. And on the far right, you can see how mobile SHE hydraulic EL 46 is performing compared to the competition. This slide also is a comparison with competitor oils and another key attribute, which is the hydraulic stability. As you know, in the presence of water, ester-based hydraulic fluids can create acids, and then consequently the acids can attack the metal components and potentially cause rust or corrosion. So in this chart, the water acidity, the lower water acidity means that you have a better hydrolytic stability. And here on the far right, we can see that mobile SHE hydraulic EL is actually best in class. Now, if we plot the ratings of mobile SHE hydraulic EL versus six key performance parameters or criteria, we obtain the following spider chart. And in here, we've compared the ratings of the new product versus commercially available mobile DT10XL 46, which is a high VI premium hydraulic oil. And we also compared it to a mobile EL Envirosyn 46H, which is a synthetic lubricant commercialized in the US. So I want to emphasize that the balanced performance is really something important you have to consider when looking at EL lubricants. So not only the biodegradable aspect is important, of course, and to develop this type of chart and this type of product, our research department has worked closely with our field engineering organization as well as with KEB or OEM, and we were able to develop this lubricant that meets key parameters which are required for long-lasting and trouble-free operations. So in short here we can see that technically the new product compares has a comparable performance with the mobile DT10XL. But the big advantage here, of course, is that it's environmentally acceptable thanks to good biodegradability and low toxicity. So while technical performance, of course, is important, and also I just mentioned that the technical performance is comparable with the mobile DTE10XL. There are actually quite a few claims, additional claims that this new mobile SHE hydraulic EL is meeting. And for example, you have the EU Eco Label, USDA Bio-Preferred, WGK1, and also the US VGP, as I mentioned earlier. So now I will hand over the presentation to Max, and he will speak about product conversion.
Okay, thank you, Oliver. So I'm going to start off talking a little bit about product conversion. And this can be quite important because it's a very good idea to try to plan and implement the conversion carefully to avoid any potential issues that you may have afterwards. And when doing a conversion to the new fluid, mobile SHE hydraulic EIL, we first need to know what is the existing fluid, and what type of fluid is it. Is it a mineral oil or is it a biodegradable oil? What type of biodegradable oil is it? Do we know if it's compatible with our new fluid? And also, it's very good to know what is the condition of the fluid. Is it in good condition, or has it started to degrade and maybe started to already cause some problems? Because if that's the case, then it's really a good idea to do a proper flushing before entering the new fluid. But of course, if we don't know the compatibility, then a flushing procedure is definitely required. And it's interesting that there is an ISO specification called ISO 15380 that specifies the maximum limits for the previous oil charge for hydraulic lubricants. And this covers all categories of biodegradable oils, the vegetable oils, the polyglycols, the synthetic esters, and also HEPR, which is, I think, low viscosity polyalpha olefins that could be mixed with esters. And the ISO specification targets a 2% maximum residue of the previous oil. And that's quite a tough limit. Usually you don't achieve that by just draining the fluid and changing. And in case the previous oil was an engine oil, then the limit is more strict. It's just 1%, because engine oils have specific additives that make them more difficult to, makes the compatibility more tricky. So doing a fluid replacement with a flush, it really helps to get the most out of your new fluid in terms of performance, of course, but it also ensures the environmental attributes of the new fluids, especially if you're changing from a fluid which is not biodegradable. Let's now look at the key steps to product conversion. First of all, we need to put safety first and ensure that we are not taking any risks. We should do proper lockout, tag-up procedures, etc., to ensure that everything is safe. Then it's a good idea to take a sample of the previous fluid to have as a reference. Unless, of course, we have just recently taken an old sample, and we would have that as a reference. And we stop the system, and we make sure to drain the system while the oil is still warm. And this is important because when oil is warm, it has low viscosity, and then we get as much out of the system as possible. And it's also important to ensure that oxidation products that can carry varnish potential will not start settling on the system surface while the oil cools. Then we flush the system by entering flushing oil, and typically that flushing oil will be the same fluid as we will use after the conversion. Then we start circulating that flushing oil and also start to operate the components. And we do that because the components can contain significant amount of oil, and also they can have some degradation products from the previous oil that we want to flush out. Then again, for the same reason, we drain the oil while it's warm. And after that, we change the filters in the system to give as good start as possible for the new fluid. Then we fill up with a new oil, and we start the system, and we monitor the system and the fluid, especially after the startup, to make sure that everything's working fine. And it's also a good practice to update all the work instructions, document the flush procedure, and label the equipment with the name of the new fluid. And that is to make sure that all all people involved will know what we have done and that we have introduced this new fluid, and that's the fluid that should be used from now on, so that no mistakes will be made. So this is the basic guidelines, but specific conversion steps may have to be taken depending on the specific application and what kind of fluids we have been using prior to the new one. So now let's look at what kind of compatibility tests we have done for the new fluid. Let's look at storage compatibility and condition monitoring after we have started to use the new fluid. We will look at two examples. We have run compatibility tests with the current product called Mobil SFC Aware H46, which is typically used in marine applications. And we have tested compatibility in a 98% versus 2% mixture of these fluids, because that's the mixing ratio that the ISO specification that I mentioned specifies. And we run both performance tests and also storage stability tests. And the performance tests include the acid number, copper corrosion and rust testing, foam performance, both tendency to form foam and also the stability of the foam. We don't want any foam that has formed to be stable. Demulsibility is an important test, ability to separate water. Air release is also important. And dry and wet filterability, which is quite crucial because we know that especially lower performing biodegradable oils often tend to plug filters. That's a frequent problem. And the results between the new Mobil SFC Hydraulic EIL and SFC Aware H is that they are fully compatible in this test scheme and in this testing ratio. We have run exactly the same tests with SFC Hydraulic EIL 46 and another product called Mobil EIL Hydraulic Oil 46, which is the common product used in the Europe, Africa, Middle East zone. And again, we have gone through the same test sequence, and everything came out with green light except for one rust test. And that is, we didn't get a very serious fail. It's quite a light fail, and we believe that's maybe just a coincidence. But since we are honest, we want to report the results exactly the way they came in. So the result in this case is that the products are deemed borderline compatible. In reality, we don't believe it's a very big issue, but of course, if you know that you have a system that tends to take in water quite often, then you need to be extra careful and maybe do an extra flushing. It's important that we always consider the conversion on a case-to-case basis. So that was the performance testing. I also run storage stability testing with SFC Hydraulic EIL against the same two fluid types. And the storage testing is done for 14 days in 3 different conditions. First condition is ambient temperature, but when the oil mix is exposed to ultraviolet light, because we know that UV light can trigger some color changes in the oil. Then we test the high performance, high temperature storage stability by putting the mixture of oils in an oven at 70 degrees Celsius. And then we do repeated cooling down to minus 18 degrees Celsius to test the low temperature performance. Because we know that some biodegradable hydraulic oils, even if they have a low pour point, they can start to form some gels when cooled repeatedly down to low temperatures. And the result is that all blends are clear and bright after 14 days. And so there is no visual observation of adverse interaction and sediment settling out of the oil or anything like that. So everything looks good. So I want to mention something about condition monitoring, because to get the most out of the hydraulic equipment, to get the most out of the new hydraulic fluid, we need to look after that fluid. And a very great way of doing that is to take oil samples and sending in for regular testing, used oil analysis. And this will help monitoring the fluid, and it will help catching any problems or issues in time before it gets to more serious problems. And that will lead to increased productivity because we can catch the problems in time and avoid downtime. It will reduce maintenance costs because we can lead to less filter changes, spare parts, etc. Improved safety because we know that, for instance, control valves that are not functioning well can really be a safety issue if we start to lose control over the hydraulic actuators. We will optimize the oil drain interval, and that will, because this is a high-performance fluid, it will lead to extended oil drain intervals in general. So we will be able to change oil exactly when it's needed, not according to a fixed oil drain interval. We may be changing the oil before while it's still fine, or running the oil for too long when we have already been getting into problems because of degradation problems. We will get longer equipment life, and all of this will lead to confidence in equipment reliability. And lastly, I want to mention that our routine use of analysis system is today called Signum. It will change name in the near future. Today it's Signum. And it's really a global program for use of analysis. And we have decades of analysis expertise built in the system. And since we have been running the system for quite many years now, we have really millions of oil samples, data from millions of oil samples in this system. So we can really pull out statistics and analyze the statistics and use that to increase our knowledge of use of analysis. And we have seen that effective use of Signum helps minimizing total cost of ownership and maximizing productivity for the hydraulic oil users. And this should be very much true also for biodegradable oils, where you, for instance, want to ensure that the product conversion has been going well and keep control over water and other contaminants. Okay, so with that, I think I hand over the word to Olivier again. Thank you.
Okay, thanks, Max. And so now let's wrap up with this presentation with key messages and that you should remember or take away after this 45 minutes presentation. So what we try to demonstrate today is that the new SHE hydraulic EL can bring you numerous performance benefits. The obvious one for any EL product is the benefit in terms of biodegradability and non-toxicity, and that will help you meet, of course, your environmental care needs. But also Mobile SHE hydraulic EL is not only about environmental benefits, it is also about balanced overall technical performance benefits. There is a robust set of industry and OEM claims, and we were able to prove excellent durability that will help you reduce your maintenance operations and, of course, reduce the inherent risks associated with that. And finally, we are able to increase the productivity of your day-to-day operations thanks to improved energy efficiency, up to 3.6%, as I showed in the previous slides. And all these performance parameters were demonstrated in numerous test rigs that we have at our research facilities, and also in a series of field tests that we carried out at our customer facilities. So I hope Max and I kept your interest high during this webinar. And if you'd like to follow up with questions, then we will start a short Q&A session right now. But also, you are welcome to drop us an email at our tech desk. The email address is indicated here. And based on the content of the question, if it's more technical, it will come to Max and I, and if it's more a commercial question, of course, it will be redirected to our sales and distributor organization. So thanks for your attention, and now let's move on to the questions.
Okay, thank you very much there, presenters. That was a great presentation. Audience members, please do send in any questions or comments that you have for the presenters, and hopefully we do have enough time to get those addressed in the session today. If not, as they said, they will respond to you at a later stage. Okay, presenters, I'm going to go in with the first question now, and the question is, the flushing fluid must be the very same oil that we will put on at the end, isn't it?
I can take that one. Yeah, I think it's good practice to use the same fluid that we put in at the end. And two reasons for that. First of all, using the same fluid as flushing fluid ensures that that fluid will be compatible, of course, with the final fluid. And secondly, as we have seen, the SOC hydraulic EAL has great cleanliness, so it's really good for cleaning out the system, and that makes it also a very good flushing fluid.
Okay, great.
That answers that question.
The next question is, does this new product contain viscosity index improvers? If so, are they strong enough to withstand shear?
So I will take that one. So no, this new product doesn't contain any viscosity modifiers. The high VI is brought by the naturally high VI of the synthetic esters that we use. So the product is relatively shear stable.
Okay, great. Thank you very much for that question. The next question is, how critical is the conversion from mineral oil to biolubricants, and what are the possible effects of contamination?
I can take that one. I would say it's quite critical to ensure that you get good performance out of the mineral oil, because contamination with the mineral can result in such things as filter clogging. That's quite a common problem, maybe the most common. And users have been experienced that filters have been blocked and has to be changed several times and for quite a long period after the conversion. With the proper flushing procedure, you can avoid that kind of problems. And of course, if the filters are plugged with some gel formation that has been formed in the oil, then that can also cause other problems in the walls of the system. And other problems can be excessive foaming and also poor air release, which can, in worst case, can lead to cavitation problems, but it can also give poor hydraulic response, as all of you has been going through. So yes, it's critical to do proper flushing.
Okay, great. Thank you for that question. The next question is, there was no mention of Blue Angel or Swedish standard claims in the deck. Does it mean that Mobil HC hydraulic EAL does not meet them?
So I will take that one. So actually, we are currently finalizing the administrative details to get these Blue Angel and Swedish standard claims. And actually, if you check now on the SP or Swedish standard website, you will see that the three viscosity grades are already listed as meeting the environmental requirements of the Swedish standard. So this is work in progress, but requires a few more days, but we will get definitely these claims.
The next question is there a product sheet available?
Yes, there is one, and yeah, actually you can contact your sales representative or your distributor to get one, but they are definitely available, the product data sheets.
Okay, thank you. Next question is, fully saturated, or what does premium mean?
Okay, so I take again this one. So yeah, the esters that we use are saturated esters, and they are the best type of esters in terms of thermal stability and oxidative stability. So that's why we get these very good results in the durability tests we've performed.
Thank you. The next question is, what do you see as the main issues that users experience with biodegradable hydraulic fluids, and how does your new project address them?
Well, it's a bit the same as the question about the need to do proper flushing when changing from mineral to the EL fluid. But you can get problems with filter cloggings, and especially when you've also been using a poorer quality EL, biodegradable hydraulic oil, you can get fluid degradation at high temperature quite quickly. And you can also get fluid degradation due to water ingress, because ester type oil can form acids when in contact with water. You can get all sorts of gel-like deposits in the system, which, like I said, leads to filter clogging, but it can also be problems with the operation of the hydraulic system, because the deposits get stuck in the balls. And also there are issues with fluids gelling up at low temperatures. And I think there have been reports also about sea leakages after conversions. And the way the new fluids address these issues is really the balanced formulation of the products. The product has excellent cleanliness, excellent filterability, both when dry and contaminated with water, good high temperature stability, and excellent water tolerance. So even if it's an ester, it can tolerate some water without starting to form esters. And as Olivier showed, it's really best in class amongst the fluids we have tested. And all of this leads to a long oil life for the fluid, and also for trouble-free operation of the system that it's used in.
Okay, thank you. The next question is, how critical is the conversion from mineral oil to biolubricant, and what are the possible effects of contamination?
I think I already answered that question, didn't I?
Okay, I'll move straight on to the next one then. When will the new product be available?
Well, I will take that one. So the new product will be available within a month from now. As I said, we are finalizing the Blue Angel and Swedish standard, and this is work in progress, but then there is some time to go to our different warehouses and distributors, but it should be available within 1 month.
Okay, great. Is there any more questions there you'd like me to answer, presenters? Ask for you.
Yeah, I think I saw one on cleanliness, and actually we do not have a cleanliness specification in this type of hydraulic products. And there was a mention to the NAS standard. Well, just to mention that this NAS standard has been obsoleted in more than 10 years ago, so now the reference is the ISO 4406. But the best way to guarantee the cleanliness is actually to filter on site when you are filling with the new product. That is generally what we recommend, because during transportation you cannot always guarantee. Well, the cleanliness, of course, is very good at the exit of the plant, but then during transportation it's more difficult to guarantee. So that's why we recommend filtration before filling the unit.
Okay, great. We've got a little bit more time left there, presenters, if there's any more questions you'd like to ask.
I see one question that is quite interesting. How would you compare Mobil DT10 XL series and the new EAL in terms of lifetime? And I think Olivier showed the slide. He showed that actually in the Mobil hydraulic fluid durability tests, it shows that the new SFC hydraulic EL actually gives a longer lifetime in that particular test.
Mm-hmm.
But of course, in terms of real-life performance, we still very much believe in the DT10XL. It's a very good fluid, and I think SFC hydraulic EL can give the same lifetime, but if, for instance, you get really an excessive amount of water into the system, then that product is still an ester and can react with the water, and the DT10XL will probably handle that a little bit better. So it depends on the system and the contamination, I would say. I'm not sure if you, Oliver, have something to add to that question.
No, I think you did well. Yeah.
Okay, great. I think that's all we've got time for today with the questions. Presenters, do you have any final words you'd like to say before we conclude today's session?
Thank you to everybody who logged in, and if there are some follow-up questions, we are of course ready to answer them. I've provided the technical help desk email address, so they will be happy to redirect your question to whoever is in the best position to answer your questions.
Okay, thank you very much. So that just leaves me to thank Olivier Boissel and Max Carlovini for what was a great presentation, and to also thank ExxonMobil. To the attendees, you will receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access through our website, which is www.business-review-webinars.com. Once this webinar ends, today's survey will appear in its place, and we would appreciate it if you answer the questions in there. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter at BRWebinars for daily updates, and join our LinkedIn group, Business Review Webinars. Thank you once again, everyone, and I hope you all have a lovely day.